Okay, everyone have a note packet?
Yeah, I just have one.
Yeah, because
I think it was one more than that.
Oh. Look in that binder.
No.
Find the 8 one. Alright, so today we are just looking at the Pythagorean theorem and its converse, which you have probably used the theorem, maybe not its converse in the past. But in order to use the theorem appropriately, you do need to know what are the parts of a right triangle. So remember that the hypotenuse is the side opposite of the right angle. It is also going to be the longest or the largest side. The other two sides of that triangle are called legs of the right triangle. Alright, so the Pythagorean theorem specifically states, again, this only works for a right triangle. Cannot be just any triangle, it has to be a right triangle. That if you have a right triangle and A and B are the lengths of the legs, and C is the length of the hypotenuse, then A squared plus B squared will have to equal C squared. Or, you can flip it around, C squared equals A squared plus B squared. Just using your symmetric property that you can flip things on either side. The only reason I talk about that is tomorrow we'll be classifying triangles as acute, obtuse, or right, using the Pythagorean theorem and a little adaptation. And this will actually be an easier way to write it because we'll also be looking at when they're greater than or less than, and it's easier if the C comes first. So, find the length of the hypotenuse. We are going to use the Pythagorean theorem, and we are going to reduce our radicals always. So no typing in our calculator to get like nearest 10. All right. So first you want to label that these would be our legs. Doesn't matter which one you label A and which one is B, but C has to be the hypotenuse, which again will be across from the 90-degree angle. Will also be the longest side. So we'll have A squared plus B squared is equal to C squared. We'll substitute in our values. A we have as 20. B we have as 21. And C we don't know. And so we would actually want to go ahead and evaluate each of these. If you want, you can type them in together. Oh, I don't have my calculator. But 20 squared is 400. Wait a second to open up. So if you want, you actually can type in 20 squared plus 21 squared. And then you don't have to write it out piece by piece. We will get 841. Now, because this is a big number, before you start trying to divide by your perfect squares, check and see if it is a perfect square. So just type in the square root of 841 and see if we might luck out. A couple of you didn't do that on your last quiz. You had like the square root of 144. And you started breaking it down. It might be a perfect square, and then you don't have to break it down. So this one is. The answer is just 29. And based on this being inches and inches, this would also be inches. Okay, now not always will they be perfect squares. And then we may have to reduce our radical. Alright, which sides are my legs and which is my hypotenuse in example 2? What are the legs and what is the hypotenuse? Right.
the hypotenuse is 20.
Good. The hypotenuse is 20. So don't always think it's the top side. It could be the bottom side if the triangle has been flipped around. So A and B don't matter which one is which. And we plug into our Pythagorean theorem. Now, in this case, you do have to actually perform your order of operations, which would be exponents first. So we're actually going to go ahead and square each of these. And then we can't go straight to square rooting because x squared is not by itself. So how would I isolate the x squared? What do I need to do? Marquise? Good. Need to solve using inverse operations. So subtract 64 on both sides. Now I can square root. So I get x equals the square root of 336, which again, test and see if there's a chance that that could be a perfect square. I don't think it is, but, and it's not. Okay, so we're not allowed to round from the nearest tenth. We would have to break this down. Again, we want to try our perfect squares list that I have written out at the top of our paper. We want to try systematically dividing until we find the largest perfect square that goes in. Some of us will think 36 goes in evenly because it ends with 36. It doesn't, but you can try. 25, nope. Ooh, 16. 16 and 21. That tells me that 16 is the biggest perfect square that goes in because 21, its only factors are 7 and 3, or 1 and 21. None of those are perfect squares. So this would be the square root of 16 and the square root of 21. We take the square root of 16, which is 4. You do not take the square root of 4, which is 2. You just leave it 4. That would be our answer. 4 root 21. And this would be inches. See if you guys can find the answer to number 3. All right, so I see a lot of you getting to the right point, but getting a little bit stuck. So we should have gotten x squared equals 525. What did you choose to break 525 down into? Lauren?
I got x equals 5 root
5 root 21. So you broke it into 25 and 21 first.
Yeah.
Perfect. And then 5 root 21. And that would be centimeters. Again, you want to pick the largest perfect square that goes in evenly. Take the square root of that perfect square. It comes outside of the square roots. All right, on the back, we're going to take a look at our Pythagorean triples, and then a bunch of just mixed solving problems for side lengths and a right triangle. So Pythagorean triples, by definition, are a set of 3 non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared. So they're numbers that always, when added together, squared and added together, get you the square of the other number. For example, 3 squared plus 4 squared gets you 5 squared. So that's why this is a Pythagorean triple. They will not have to be reduced radicals, they'll always be whole numbers. The next one is a 5, 12, 13, an 8, 15, 17, and a 7, 24, 25. I suggest you memorize these. You don't have to, but there's a good chance that you may struggle to finish problems as fast as you should be able to if you don't memorize them. So what this tells you for a Pythagorean triple, if you were to know that 2 of the legs were 5 and 12, if you know the triples, you would just write 13, because you know the 5, 12, 13. Otherwise, you'd have to do the Pythagorean theorem, which takes time. Okay? Now, you do want to be careful that obviously the biggest number would have to be which side in the right triangle, right? The hypotenuse. So be careful if they were to do something like this, which I don't remember where it shows up, but it's in a homework question or it might be given in the notes below. If they were to give you 3 and 5, you cannot say that this is 4. Okay? A Pythagorean triple would only work with 5 being your hypotenuse. So you would still have to do the Pythagorean theorem. Now, you can come up with infinitely many more of these things if you multiply each of them by a constant number. So you could multiply all of these by 2 and get a 6, 8, 10. That's another triple. You could take each of these and multiply them by 10. 50, 120, 130. That's another triple. You could do this like forever and ever and ever with as many numbers as you want. But these are the bases, the most common Pythagorean triples you're going to see. Okay. So down here it says, if you multiply each number in a Pythagorean triple by the same whole number, the resulting numbers also form a triple. So 6, 8, 10, just like I talked about here, is a 3, 4, 5 times 2. The 70, 240, 250 would be this one times 10. Now the next example asks us to find the third whole number that would create a Pythagorean triple. So we have a 12, 35, blank. So what you're going to want to do is you're going to want to put a variable in there, like x. Now, there are two cases. The problem is most students assume that this has to be bigger than 35. It doesn't necessarily. It could be between 12 and 35, or it could be smaller than 12. But you have to set up two scenarios. One, where 12 squared plus 35 squared will equal x squared. And if that's not the case, then 35 would have to be the largest number. So the other option would be 12 squared plus x squared equals 35 squared. So these are your two possible scenarios. Okay, only one of them is going to get you a whole number, and a Pythagorean triple has to be a whole number. So if one of them gets you a decimal, you just eliminate it. So we'll do this left one first. 12 squared plus 35 squared will get me 1,369. Under your square with the square root. And let's see if we get a whole number here. And we do, 37. Which means this is my answer. If you do the other one, you're going to end up getting a decimal or a radical, and it has to be a whole number. But there is a case where sometimes you'll do this and you will get a radical, which means that you must have to check the second case. We actually don't have to check this one because this worked. Okay? If the first scenario fails, then you have to check the other one. All right, the rest of them are just mixed problem solving. A lot of these are triples, so a lot of them don't require work. Number 5, what should the value of x be? Or piece? 10. This is again a 3, 4, 5 times 2, which gets you a 6, 8, 10. No work required if you do Pythagorean triples. How about the next one? What should the value of x be? Lexi? 5. This is another triple. This is your 5, 12, 13. We see that 13 is the hypotenuse, 12 is the side, therefore 5 has to be the other side. No work required. If you don't memorize the triples, you're going to have to do x squared plus 12 squared equals 13 squared, square each number, subtract them, and square root them. Okay. Pythagorean triples are your friends. They save you a lot of time and work. How about the next one? Again, it might not be from our direct list up here, but could it be one of these triples multiplied by a constant term? Maddie? It is 12. So this was a 3, 4, 5 times 3, which gets us a 9, 12, 15. So 12 was the missing number. Try to do these with triples. Again, some of you won't like triples. I don't know why. You just don't like them. They save you so much time, not only in this chapter, but for the rest of the year. We're doing volume and surface area and stuff. So this one right off the bat does not look like a triple that's in our list. But does anyone see how we could modify one of the triples? Justin?
8, 15, 17.
Times 2. So this should be 34. Done. Now this is the one I was talking about. You want to be careful. This looks like it's a 3, 4, 5. But notice that 5 is not the hypotenuse. Okay? So since 5 is not the hypotenuse, you cannot use the triple. The hypotenuse cannot be smaller than one of the legs. So this is not a triple, which means we have to do the Pythagorean theorem. We have our A, our B, and our C. So we would have 5 squared plus 3 squared equals x squared. Again, make sure the hypotenuse is what your C value is. And we would just solve out from there, squaring each of the numbers. And we'll get 34, which is not square rootable. So we actually just leave that as our answer. It's not divisible by 4, 9, 16, 25, and obviously not 36. So remember that sometimes your square roots are not going to be reducible. Okay, now the last one is a multi-step problem. It has two triangles in the picture, and also technically a quadrilateral if you look at the big shape. Okay. So in order to find out what x is, we would need to use this triangle. In this triangle, we don't know what this side is. So we're going to have to actually do the Pythagorean theorem 2 times. Once on this triangle to find out what this is, let's call it B or A. And then a second time with the second triangle to find out what x is. So this would be our A, our B, and our C in terms of the purple triangle. So we'd have 2 squared plus B squared equals 4 squared. Make sure you square the numbers before you subtract. You cannot change the order of operations. Subtract 4 on both sides. Now, normally we would reduce this, correct? Square root of 4, square root of 3, 2 root 3. You can do that. However, since this is not your final answer, you may want to leave it as the square root of 12. Why? Whenever you plug this back in, you're going to have to square it, right? A squared plus B squared equals C squared. So whenever you square a square root, they just undo one another, so you'll get back to 12. If you reduce it to be 2 root 3, you'll end up squaring 2 root 3, and a lot of you just may make a mistake algebraically when you square that. So it's up to you, it doesn't really matter, but one of these will get you your side length. Then you do your Pythagorean theorem a second time, which would be, this will still be our B value, we'll say this is A. So 6 squared plus the square root of 12 squared equals x squared. So we'll get 36. Again, when you square a square root, it just goes away, leaving us with 12. That's the only reason I said you might not want to reduce your radical. If you do reduce the radical, just make sure when you square it that you do get 4 times 3, which gets you 12. Just want to grab your homework on the way out the door. So don't wait 12 minutes. And then to finish up this example, we would get, adding those together, 48 under our square with the square root. We should get x is equal to 4 root 3. The closer just asked us about how far is it to paddle from one dock to the other. So you can see our docks are located here and here. So they're asking us if we were to go across the lake, we would just need to use our Pythagorean theorem. Now this one does say to round to the nearest tenth, which means we do not have to reduce the radicals because we are going to get really big numbers here. So once we square these and add them together, we should get 185,000. And then whenever we square that, we will get that it is approximately 430.1 meters. And only round to the nearest tenth if the directions would tell you to do so. Okay, on the homework, remember to look for triples. They will save you a lot of time.